All right, so we're going to talk about sets. So one main application of sets is constructing relations. A set is a well-defined collection of distinct objects, and the objects of a set are called members or elements, and they're symbolized by this symbol that looks like an E. It kind of looks like a comb, but it is looks a lot like an E. So understand that elements can be anything: numbers, peoples, jobs, letters, dogs, cars, food, cards, pets, animals, names, colors, and the list goes on. They can be anything. There are two ways to describe sets. The first one is by words. So A is the set whose elements are the first four integers, or by using curly brackets to enclose the list of objects. So example B is equal to the curly bracket 1, 2, 3, 4. Now this set A and this set B are equal sets because they contain the exact same elements. Therefore, set A is equal to set B. This one we just described in words. This one is in a curly brackets. So the empty set is a set that contains no elements, and it's either symbolized by the curly brackets that are empty, or the empty set, which is a circle with a line through it. So an example of that would be a month that has 32 days in it. None of the months have 32 days in it, so we just need to be aware of that. All right, so let's go look at some examples. So example 1, these are going to be the examples we're going to actually kind of look at. So we could look at C is the set of colors in the American flag. And if we look at D is equal to red, white, and blue. Are they the same set? Well, the colors in the American flag are red, white, and blue, so we can state that C is equal to D. They are the same. Now we talked about the empty set, and remember the empty set is an empty set because there's no examples that would fulfill that. So we had the example that there were 32 days in it. Now, one of the things you have to be careful about that is if you're looking at a month that has 32 days in it, that would be a good example. You can't use an example like a month that has 22 days in it, because a lot of people think, well, every month has more than 22 days, so no, there's no month that only has 22 days. But when you say a month that has 22 days in it, every month has 22 days. It has 23 days, 24 days, 25 days, 26 days, and so forth. The shortest one is February that has 28 days, except every fourth year it has 29. So when we look at a set that has 32, none of them have more than 31 days. So this one would be true. So be careful and think about not just, well, it's this, but would it ever be that? So let's look at another example of an empty set. And these things can change as people are exploring space in that, but I'm going to use this example because for now it works. If we looked at the astronauts who have landed on Saturn. So we couldn't say who have landed on the moon because people have. We can't say the astronauts who have gone into space because they have, but astronauts who have landed on Saturn. We've looked at Saturn through telescopes, but nobody has landed on it, so that would be the empty set. All right, let's look at another example. What about the set of people who are 100 feet tall? So there's no person who is 100 foot tall. Now, some people might be inclined to say, well, 10 feet. But you can't know for certainty that never, ever, ever in the existence of people has anybody not been 10 feet tall. The likelihood is probably small, but you really want to make sure you go big or stay home kind of situation here. If we go with 100 feet, there's no person who was 100 feet tall versus going with 10. So really push it so that you know nobody can negate that. So you want to make sure it's truly an empty set and that somebody can't come up with an example. So another example of this could be, I'm just going to write some more here. What if we look at the set of fish who have climbed trees? Well, no fish have climbed trees. We're not talking about, well, a person in a fish costume. No, we're not going there. But a set of fish who have climbed trees. What about the set of dogs who drive cars? Or the set of cows who are purple with pink polka dots. Usually we see black and white cows, brown and white cows, black and white and brown, but we don't normally see the set of cows who are purple with pink polka dots. Alrighty, so now let's go look at rosters. So a roster is a form in which the elements of a set are listed. So this is similar to what we looked at earlier. We're looking at the roster set of 2, 4, 6, 8. And ellipsis tells us that 3 dots, which mean the set of elements continue in the same pattern. So that's the 3 dots there. So 1, 2, 3, 4, 5, comma, dot, 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 tells us that's going to go 6, 7, 8, 9, 10, and going on and on. It goes all the way up to as far as you can go because those dots means it's never going to stop. Now, here we have the dots in the front and we have them in the back. So we know we're going from, way over here. We know the one that's before that would be -3 and -4 and -5 and -6 and going this way. We're going towards negative infinity over there, and here we're heading towards positive infinity. We would go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sometimes they'll put them in the middle to show that they are inclusive in not writing out everything. So we understand that each of these sets contain more elements than we actually see listed. Now we're going to talk about some sets that are intersections and unions. So the intersection of 2 sets, A and B, is the set of all elements common to both sets. So the elements are in set A and set B. So right here in the middle between the 2 circles, this is set A, this is set B. Where they overlap, that is the intersection. So A intersect B is denoted by A, and it's like an upside down U. It's not necessarily a U, but it looks like one. B. Think about that kind of looks like an N. So A, N, think about an N. It's not an N, but think about that for intersection. And think about the amount of things you could put up there. You could only put a few things on top of this, or they would start, if I piled them up, they would start to fall over. So I can only fit a few things on top of there. That's where they intersect. Think about an intersection if you have one street that goes this way and one street that goes this way. The intersection is just what the streets have in common. These 4 corner points at the intersection, that's an intersection. It's not this whole street and that whole street. It's just where they overlap. That's the intersection. So think about that being just a little bit of the whole thing. Now the union of two sets, A and B, is the set of all elements that belong to either set of the sets. So the elements are in set A or they're in set B. So this is an and. They're in this one and that one. Here they're or. They're in this one and they're also in that one. Or they're also in that one. Either way you want to look at that part. Just think about this as an and this is an or. Now on this one it does look like a U. It's not a U, but it looks like it. So on the first part, remember, we're looking at the intersection. I can only put a few things up on top of here, and then they'll start to be too tall and they'll topple over. But here, the union, I can put lots of things inside of here because it's going to hold lots of items, because it's like a cup or a bowl. I can pile all of both sets in there. So that might help you keep them straight. So it's going to be everything in A and everything in B. And then, so let's go look at some examples of those, and then we'll come look at subsets. All right, so we have, let's switch colors here. Example 4. If we have the set A is equal to 2, 4, 6, and 8, and B is equal to 2, 3, 4, 5, 6, 7, and 8. So I want to look at the intersection and the union. So if we're looking at A intersect with B, I'm just looking at what they have in common. So I can start out with my list of my numbers. Well, they both have 2, so I'm going to make my curly bracket. Never write parentheses when you're writing a curly bracket. It needs to be a curly bracket. So I have 2. And then they don't both have 3, but they both have 4. They both don't have 5, but they both have 6. They both don't have 7, but they both have 8. So this is my intersection. That's what they both have in common. So we can make a side note here that this is the in common part. Now, if we look at A union B, this is the part where they are all together. And there's 2 ways you can do this. You can, this is going to be a curly bracket situation again. You can look at A and you can look at B, and you can go in numerical order, or you can list all of one set and then list all the other set. So I'm going to list set B first because it's the bigger set. So I'm going to write all of set B, and then I'm going to see if there's anything in set A that's not in set B. All right, I already have the 2, I have the 4, I have the 6, and I have the 8. There's nothing left in set A that also needs to be in here because all of set A is in set B, which leads us to the next part on our handout here, is that it's called a subset. If a set where all members of one set are also elements of another set, it's symbolized by this, kind of looks like a C. It's not a C, but it looks like it. And that means that that set is a subset of the other one. So this is where all of this set is inside of the other set. In this case, or this example, B is a subset of A because all of B is inside of A. So B is a subset of A. In our case over here, all of A is inside of B. So we can say that A is a subset of B. And sometimes you'll see it written as A is a subset or equal to B, which means it could also be equal to it. Our case is not equal to it, it's just a subset of it. But you might also see that situation where you're going to see that. All right, so let's go look at another example. So if we do set A, let's flip pages here. So this will be example 5. So if we have set A is equal to 1, 3, 5, 6, 7, 8, and 9, and set B is equal to 2, 4, 6, 8, 9, and 10, we want to find the intersection and we want to find the union. All right, so looking for the intersection, we're going again down our list of numbers to see what they have in common. So, I don't see 1, I don't see 2 in both, I don't see a 3 in both, I don't see a 4, I don't see a 5, I see a 6. They both have a 6. They don't both have 7, but they both have 8. They both have a 9, but they don't both have 10. So what they have in common is 6, 8, and 9. Now let's find the union. So remember I told you could do it one of two ways. You can list one of the sets and then fill it in, or you can write them in numerical order. It doesn't matter either way. I'm going to show you both ways that mean the same thing. So they're both about the same length, so I'm going to write 1, 3, 5, 6, 7, 8, and 9. That's all of set A. Now I'm going to go to set B, and I see I need a 2, I need a 4, I already have the 6, I already have the 8, I already have the 9, I need to also put the 10. Or you can do it numerically, and you can go back and forth. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Either answer will be a correct answer. You don't have to put them in numerical order. Sometimes when you try to do that, it can mess you up. Now, not always will these sets be numbers. You can have a set with letters. So let's go to example 6. So set A is A, B, D, F, G, K, and M. And set B is C, F, H, J, K, L, M, and N. So we can do this with letters. So the the intersection first. So intersection of A and B, what do they have in common? So they both don't have A or B or C or D. Oh, they both have an F. G, H, they don't have I, they don't have J. Oh, we have a K. L, oh, they both have an M. So those are the letters that they have in common. And then you can write it all as one set and then fill in, or you can put it together alphabetical. A union B, so we have A, B, C, D, F, G, H, J, K, L, M, and N. So if you want to do it alphabetical, you can. It doesn't matter either way to me. All right, so let's look at one more example. That's a little bit different. So, example 7. If we're looking at A is equal to 3, 5, and B is equal to 1, 3, 5, 7, and 9. So we can see finding the intersection A intersect B and finding the union A union B. So the intersection, they both have a 3 and they both have a 5. And the union is going to be set B. This is similar to the first example that we did when we started getting into subsets. So it's all going to be all of set B because set A is inside of there. So again, we can say that A is a subset of B. Make sure that you're careful about that. It is not B is a subset of A. It is A is a subset of B. All right.